We're Team W3, and we designed a advanced water treatment facility under the guidance of Black and Veatch. This is our team, me, Ravidu, Josue, Kyla, Giselle, Jabez, and Sal. Thank you to our industry advisors at Black and Veatch and also our faculty advisors at UCI. This is the table of contents, and this is everything we'll be going over in our presentation. For this project, we'll be designing a advanced water treatment facility that will be taking in secondary effluent coming in from an existing water reclamation facility located in Coachella Valley. For the secondary effluent, we'll be taking in 3 MGD and treating it to potable standards. This water will then be recharged into the local groundwater basin for local agricultural use. And this is our site location.
Hi, my name is Josue, and today I'll be talking more about our source water characteristics. The following two graphs below show our current water quality that's coming from the primary/existing treatment facility, and this is the water we're going to be receiving and treating to a higher standard. The following slide, which focuses on Title 22 requirements, details contaminants that we must treat to a standard that's acceptable, and more on Title 22 is as follows. So Title 22 refers to the California Code of Regulations, which establishes standards for treatment and use of recycled water in California. It specifies minimum treatment levels required for recycled water. And the most commonly referenced standard is tertiary treated recycled water, which is used for secondary treatment, filtration, and disinfection.
This is our overall process flow diagram. We've grayed out the parts in the beginning that are existing facilities that were not within the scope of our design, which includes the clarifiers and equalization tank. And this is just a side view to show kind of the dimensions of each one of the MF, RO, and UV skids, and as well as the brake tanks. This is our overall process flow diagram. We've grayed out the facilities that were already in existence that were outside of the scope of our design, which include the clarifiers and equalization tanks. The diagram is to show the dimensions of the skids and is to scale vertically, but we've shortened the horizontal pipes to fit it all into the diagram. It starts from the equalization tank, goes to a pump that feeds feed pumps that goes into each individual skid, and also shows the brake tanks that were designed for a 15-day retention time. And here is just an overview on the map of the existing facility to show kind of a general area requirement for the facility. And now I'll hand it over to Kyla to talk about the ultrafiltration.
My name is Kyla, and I'm going to be discussing the ultrafiltration, and we decided on this because it provides higher quality standards compared to microfiltration. So given the data sheet, we were able to configure the system to 10 Pure Aqua UF skids. This means we'll have 40 UF vessels per skid, which will each have a capacity for 400,000 gallons per day nominal throughout. The net permeate capacity will be approximately 2.8 million gallons per day with the backwash and maintenance losses of 0.2. And the dimensions that were calculated is approximately 120 to 45 feet. This is a layout of what our design will consist of. So it will have a clean in place tank with the dosing pump, as well as a brake tank, which will have a backwash pump for the backwashing system.
And for the RO layout, we decided to go with the Pure Aqua TW600K skids. Each one has a maximum flow capacity of 600,000 gallons per day, which would require 5 skids, but we've added a 6 for redundancy. Each one consists of 91 8-inch membranes per skid and has an operating pressure of 150 to 250 psi. Each skid has its own feed pump that feeds into the skid. As it exits, goes through a pressure valve, a flow meter, and regulator valve before it gets to UV.
Okay, thank you, Sal. Giselle will now be going over the UV system. We decided to do an advanced oxidation process. We decided to settle with UV from Trojan UV, which is a common manufacturer used without all wastewater places. OC San uses this one. We decided to use their UV Flex 100, and each system can treat 1.25 million gallons per day. At this point, we have lost in the UF system as well as the RO system. So now we're left to treat 2.52 million gallons per day. Considering that, we'll be only using 2 banks operating at all times. That will be treating around 2.5, and then we'll have an extra system just for redundancy, just in case any time we need to go offline on one. This one would treat a UV dosage of around 1,200 millijoules per centimeter squares. And here, this is where we meet our Title 22 compliance. This is where our water will get treated to Title 22 standards using the UV lamps. As you can see in the image, the top image is the overview, if we were looking at it from the top, and the bottom one is the side. All the little circles is where the lamps will enter. There's 32 lamps in each little rectangle, making 96 lamps per system. And now I'll be passing it on to Kyla to discuss the pumps.
Thank you, Giselle. I'm going to be discussing the pumps, and we settled with the Xylem water solution, which will provide the UF feed pumps as well as the preliminary pumps, the RO preliminary feed pumps, as well as the injection well pumps. We added redundancy to each pump stationing just to account for maintenance. We calculated for the net positive suction head available and made sure that it was greater than the required for design purposes. And for the instrumentation, we made sure that pressure gauges, flow meters, isolation valves are installed up and downstream for each pump.
As mentioned earlier, we do see some losses throughout our system. Here is a table of where we see some losses. And as we go in from the air influent to our ultrafiltration, we have our 3 MGDs. And then due to backwash, we lose around 0.2. Once we go from UF to RO, we have 2.0 MGDs. And within that system, we lose around 0.28. And then from RO to UV, it's standard, we don't lose anything. So then our outcome effluent treated will be 2.52. So around 2.5 million gallons per day will be treated at our plants. We also took account of system losses throughout our whole system, which uses friction loss and minor losses. Throughout our system, we have different lengths of pipes, such as 100, 10, 25, 75, 11, and 100 again, depending on where we're at. The Hazen-Williams equation was used to calculate the friction loss. We had concrete steel lined pipes, so therefore our coefficient was around 140. And then we just took account of the different factors of the pipe length as well as our flow at the time, and to calculate friction loss. And minor losses were also calculated and accounted for in our systems.
Thank you, Giselle. I will now be talking about the control, instrumentation, and automation for our system. Starting with our valve, the purpose is to control the flow of water in certain parts of the system. And next would be our regulator valve that has the purpose of maintaining desired downstream pressure. Next would be the check valve, which allows the fluid to flow in one direction only, preventing backflow as well. Next, we have the pressure gauge, whose purpose is to monitor the pressure within the system or within certain parts of the system. And similarly is the flow meter, whose purpose is to measure the rate of flow throughout certain parts of the system. Next, we have pumps, which purpose is to move water from certain parts of the system also to other pumps meeting the minimum required pressure. Lastly, we have T's, which splits or combines the flow in piping systems. For our system, we want to maintain a flow of 3 million gallons per day. And we will have a permeate output of 2.5, not permeate. We will have a treated water output of 2.5 million gallons per day after all the system losses. We have a budget of $20 to $40 million for our design, and we are limited. We had to limit land use based on the constraints of our site layout. We are also treating the secondary effluent to Title 22 standards. For our design, we considered a basin recharge method as well as injection wells, but we have decided to go with injection wells for our final design. And for our method of disinfection, we had the option of choosing ultraviolet disinfection, chlorination, or ozonation. Our final design has chosen ultraviolet disinfection as our disinfection. For our pump scaling, we had to scale each of the different pumps that we have throughout our system, being the basement pumps for the ultrafiltration and also the reverse osmosis, as well as the feed pumps for ultrafiltration and reverse osmosis. And lastly, we had to consider our piping and how long we would make each pipe, as well as our material selection to help to make sure that we meet our system requirements.
I'm going to be talking more about our estimated costs right now. And the breakdown of our known costs are as follows. We went forward with 6 TW-600K pure aqua reverse osmosis kits, and they were valued at approximately 500,000 each. And 10 ultrafiltration pure aqua skids valued at 900,000 each. We also went forward with 3 Trojan UV Flex 100 systems valued at 500,000 each. And from online research, I was able to gather average cost for excavation per square foot, which amounts to about $5 per square foot. And multiplying that by our pump stations and how much we would have to excavate per pump station, I was able to get $198,000 for pump station number 1, $269,500 for pump station number 2. And after adding all the values together and multiplying by a factor of 2.35 to account for labor and installation, our total cost now amounts to $32,648,750. It's important to note too that our given budget for the project was 20 to 40 million, and our proposed final number falls within that range. And it also gives us some space for any additions or subtractions of the total cost.
Thank you for listening to our project. We believe our project design has the potential to serve the people of Coachella Valley and surrounding areas. We look forward to presenting to you and hearing your questions in June.